Hello, I'm Gary. My project is deriving CT perfusion imaging using deep convolutional neural network for functional guided radiation therapy. First, I will introduce lung cancer radiation therapy and pulmonary functional imaging. Then I will talk about the design of neural network. Then I will go through the preliminary results. The last is future study. According to the World Health Organization, lung cancer is the most common cause of cancer deaths in Hong Kong and worldwide. People died from lung cancer equals the add up of prostate, breast, and liver cancer. And 85% lung cancer patients were diagnosed with non-small cell lung cancer. This cancer patient has a short survival, and the standard treatment for this is chemoradiation therapy. However, lung radiation has side effects. In the short term, it will induce radiation pneumonitis, which occur in 30% of patients and fatal in 2%. In the long term, it will cause pulmonary fibrosis, which will lower the function of the lung. So one solution for this is lung functional avoidance radiation therapy, which aims to limit dose delivered to well-functioning lung region. This technique needs lung functional imaging, such as perfusion spectral CT, which has been commonly utilized as a predictor of pulmonary function after surgery. However, this imaging modality has limitations. Its low accessibility for radiation oncology departments, and its invasive technique and high cost. Our proposed work will derive CT-based functional imaging using artificial intelligence that will be available for hospitals without SPECT CT scanners, as is no intravenous injection needed. To fulfill this aim, we will use artificial intelligence to build up a model to connect the CT image with lung perfusion images. After acquiring the SPECT CT image from lung cancer patients, they will have image pre-processing. The aim of it is to get the most useful information out of the image pairs and speed up the converge of the network. While the network generates fake functional regions, we develop a hierarchical model for pulmonary functional imaging, use cost to find synthetic strategy. In this model, the processed paired image will be used to synthesize the cost probability map, which is then divided into three-level maps. These three maps will concatenate with the processed CT image and generate the input of the file synthesis. In the preliminary results, I will only show the results of the cost synthesis. The backbone of this model is a 3D fully convolutional neural network. It uses unit-like encoding-decoding structure, and we use dilated convolution to avoid the loss of spatial information, and we use dropout layer and early stopping to avoid overfitting of this network model. Preliminary study, we acquired 30 lung cancer patients with SPECT CT perfusion scans, and the left and right lung for individual studies were separated, so we can get 60 cases. In the training set, we use 50 cases, and in the testing set, we use 10 cases. From the quantitative evaluation, in the testing group, we got the mean correlation coefficient of 0.68, which demonstrating a moderate positive correlation. Qualitative comparison, as we can see, no matter the defect region is on the upper lobe or the lower lobe of the lung, it can be predicted. In the future, we will develop a Data augmentation method uses 3D deep convolution generative adversarial network, and we will investigate the potential of clinical efficiency of the AI-assisted pulmonary function imaging method in functional guided radiation therapy. Thanks for your attention.